Hello everybody and welcome to Unit 2, Day 3, Angles and Angle Relationships. We've got a lot of stuff to go over here, so I will get right to it. Today you're going to learn how to classify angles, identify and apply angle relationships, and by the end of class you'll be able to name and classify angles, add angles, and solve for missing values when given information about a pair of angles. So let's start by naming the angle here. So you can see this angle. We have several different ways that we can name this angle. We can call it angle CAB. Notice the angle symbol in front of it. It's much easier to write that symbol than to write out the word angle. So you make this symbol, it's CAB. So you start on one side, go to the point that's in the middle, which we call the vertex, and then down the other side. You could also start at point B and go the other way, which would give us the name angle BAC. And sometimes when we have one angle sitting there by itself, we can name it just by its vertex. And in this particular case, we could call it angle A. So those three names would all apply to this angle. Now, as I mentioned, the point kind of in the middle of the angle where the sides meet, we call the vertex. So our vertex there is point A. And the other things we call sides. The two sides of this angle, notice there's a point here where it starts and it goes off forever in one direction, as you can see by the arrow, and hopefully you remember that's called a ray. So one of our sides is ray AB, that's this side, and the other one is ray AC, which is this side. So here's another example. We have a picture here, and it contains three different angles. So we're going to name those three angles. So the first angle is angle HGI. So again, you start on one side, go to the vertex, and then down the other side. You could have also called this angle IGH, but it's still the same angle. Another angle we have here is angle HGJ. So the big angle here, angle HGJ. And the third one is angle JGI, or the smaller angle on the bottom half. So again, when you see multiple angles, we couldn't just say angle G, because I wouldn't know which angle you're talking about, because all of them have a vertex of G. Classification of angles. Angles we classify by their measures. So an acute angle has a measure of less than 90 degrees. Here's a picture of an acute angle. A right angle measures exactly 90 degrees. And a right angle, you've all seen, looks like that. They're usually marked with a box at the vertex so that you know it is a right angle. An obtuse angle is more than 90 degrees but less than 180 degrees. So it'll look like this. You can tell it's more than 90 degrees because it just looks like it's more than 90 degrees. And then one that might be new to you guys is a straight angle. A straight angle measures exactly 180 degrees. It looks a lot like a line. So last time we had the segment addition postulate. We have the angle addition postulate, which is really no different. It just tells us if we have an angle, like this angle, RST, and we divide it into two smaller angles by putting another ray inside, the sum of the measures of the two smaller angles will equal the sum of the measure of the bigger angle. Or the measure of angle RSP plus the measure of angle PST will equal the measure of angle RST. So let's get an example and see what that might look like. Example number 2. Sorry, we're not ready for that. We know that the measure of angle CDF plus the measure of angle FDE is going to equal the measure of angle CDE. I'm going to substitute in what I have. So angle CDF is 4x minus 8. Angle FDE is 5x plus 13, and that equals the measure of angle CDE, which is 140 degrees. When I combine like terms, I get 9x plus 5 equals 140. Subtract 5 from both sides, 9x equals 135, and divide by 9, x equals 15. But that's not what we're looking for. We're looking for the measures of angle CDF and the measure of angle FDE. So I need to take my 15 and plug it into both of these problems. So the measure of angle CDF ends up being 52 degrees, and the measure of angle FDE equals 88 degrees. And to check, which is always a good thing to do, if we add these two together, 52 plus 88, it equals 140 degrees, which is the measure of angle CDE. An angle bisector is a ray that divides an angle into two congruent angles, two equal parts. So if we look at this picture in number 3, it tells us in this diagram, ray SP bisects angle RST, so it cuts it exactly in half. And then it tells us the angle RSP is 19 degrees, and it wants us to find the measure of angle RST. Well, I know that RSP has to equal PST, because if that's a bisector, it cuts into two equal parts. So angle PST also has to be 19 degrees. By angle addition postulate, I know that RST has to be the measure of RSP plus the measure of PST. And if I substitute in, I get the measure of angle RST equals 19 degrees plus 19 degrees, and the measure of angle RST is 38 degrees. Here's some new vocabulary for you. I know how much you love vocabulary. Two angles are complementary if the sum of their measures is 90 degrees. Two angles are supplementary if the sum of their measures is 180 degrees. And two angles are adjacent if they share a common vertex and one side but have no common interior points. Adjacent is just a math word for next to each other. So if I told you that angle 1 is a complement of angle 2 and the measure of angle 1 is 64 degrees, we want to find the measure of angle 2. So angle 1 plus angle 2 is 90 degrees. That's the definition of a complement. We're going to substitute in what we know. We know that angle 1 is 64. So 64 plus the measure of angle 2 is going to equal 90. And if we subtract 64 from both sides, the measure of angle 2 is 26 degrees. Letter B, given that angle 3 is a supplement of angle 4, and the measure of angle 4 is 28 degrees, find the measure of angle 3. So again, if it's a supplement, they add up to 180. So angle 3 plus angle 4 equals 180 degrees. We're going to substitute in what we know. So the measure of angle 3 plus 28 degrees, which is the measure of angle 4, is 180. If we subtract from both sides, we end up with the measure of angle 3 at 152 degrees. Okay. Given that angle ABC and angle CBD are supplementary, find the value of x and the measure of each angle. That we're going to do in class. But you guys should be able to figure it out on your own. All right. Two adjacent angles, so two angles that are next to each other, are a linear pair if they form a 180 degree angle. In other words, a straight line. These angles are also supplementary. This picture shows you an example of a linear pair. Angle ABC and angle CBD are supplementary, and they sit on, and they're adjacent to each other because they share this side. So they are a linear pair. Vertical angles are always equal or congruent. They're often thought of as opposite angles. They must have a common vertex. So in this picture, where we see two lines crossing, this angle and this angle are vertical angles. They're both 30 degrees. These two angles are also vertical angles. They're both 150. Notice the two next to each other, you can see a line and they're adjacent. They add up to 180. The next problem on that page, example number 6, this one's kind of a tricky one. I would like you to try this on your own, and we will go over this in class as well. Thank you very much for watching the video, and have a great day.